Hello, this is Wayne Roseberry of Software Testing. So I recently recorded a video of myself doing some tests on a no-code automation tool, Context QA. And as part of that testing, I used a website that I built called Data Maker, which I described as problematic. And if you watch the video, I talk about how lack of IDs inside of the objects in the page made it very difficult for a context QA and really anybody, never mind the self-healing things in the tool, really anybody trying to write automation would have found that a challenging page to work with because of the way the web page is structured. It's not designed in a way that helps the test, control, discover, or work with the objects in the page relative to the business problem, relative to the data problem that the page represents. So I refactored the page. I made some changes. It's my page. I can change it all I want. But it really describes a relationship that anybody testing, whether it's a separate person who is a tester working with a page, or it's the developer themselves, is going to run into if you're trying to write automation that happens at the web page level, right? Coming in through the top, through the UI, you're going to have problems, and you want to build testability into the app. Something about the app that makes it easier to test, makes it easier to inspect, and work with and find bugs and such. The interesting thing about testability is that frequently it exposes flaws in your application where you have conflated layers of the application together. The presentation of the application for visual experience, for cognitive experience, through the human senses is one way of modeling the world, but it models it in a way that is necessarily distant from the underlying business logic. There's a relationship between the two, but via the tools, the languages we use to express that, and just the way human perception works, it creates a distance that has gaps in it, right? And normally we close those gaps with social understanding, cognitive understanding, context of how our universe works, and psychologically impose understanding on a UI, understanding on objects that make it work for us. But that understanding is, it's a jump away from what the application was doing with the data, and actually may be a very different reimagining of the relationships in the data that we're looking at visually, or audio, or whatever medium that takes in our senses. And this is part of the reason why automation against a user interface is so difficult. It's an interface that is made for human behaviors, human senses, right? And not for robotic control, not for an automaton to say, is this what I want? Okay. A lot of that is lost in the programmatic expression of that user interface, which is all the automaton has to work with. This creates interesting design problems, right? How do you inject something into the user interface that still functions in the way a user interface should function, but represents the information relative to the business problem that the automaton, that the scripts, the tools, whatever, are trying to manipulate, work with, usually check, right? Usually I've got a condition, I want to see if I got what I wanted. But other things, just taking it apart and analysis and such as that, when there is that distance between what the app was working with to derive something and what it presented to the end user. So you have to actually do some design work. And even when you've got simple constructs in a page, you have to think about what's the best way to represent this so that something via script, via code, can take this apart and find it in the UI and say, is this what I want? And then do interesting processing with it that helps the testing. Okay, so you come in with kind of two ideas, two things in mind. One, what is the underlying concept that we are trying to work with? This is usually data, but it might be something else. It might indicate state. It might indicate prior action. It might indicate something else that's happened. But there's some concept in the business logic of the app that the test code or tool usually wants to work with. So that's the first. What's the underlying concept we're trying to express and understand and work with? The second is, what are we trying to do with it? What are the tasks at hand for the sake of the testing or for the sake of the automation, and how do we facilitate that? Those two things are what should guide engineering of markup or testability or any solution. So I went through this exercise with DataMaker and made some changes to the app that I'll cover that in a separate video, or maybe this one. Let's see how the time works on editing. That made it more robust, made Context QA pick a much more resilient set of locators to use in navigation that were resilient to changes in the app, whereas the prior version just fell apart because it was set up to fail by the condition. Whereas by an app that's well designed, that has taken testability into account, it made it more resilient. And I'm going to describe the design process and thinking that went into that. Because it's interesting, as each of the items had a slightly different approach to the design of the markup. And you'll see how I'm taking into consideration the behavior of the app underneath, as well as the problem I want to test when I do that. Okay, let's go take a look. All right, let's talk about the random schema example problem that I was having earlier with DataMaker. If you remember the application, it was web page, had a couple of select items, which one of them was which schema object we were working with. Okay, then underneath it we had a table. First column we would put in whatever schema object's description in JSON was, and then on the right we would put random examples of the schema object. And this is where we were having our problem, because when we were trying to grab it for recording so that we could automate against it, it had to figure out which one we were clicking on. And the definition of these items was in a span, where we'd have the span, the random text, and of course close the span, as you'd expect. But there was no ID on the span. These were all contained under a div that had an ID on them, and it was called random examples. Okay, but the individual did not have a span on them, each one of them. So when we did the recording, Context QA would try to come up with a strategy for which locators to use, and it collects several. The first one that it would collect, it would use in a getText method that would look for things based on the text inside of a control, in the text element of a control. So that was the first one it would use. The second one it would use is path-based, and so it would start with that parent div, random examples. Okay, and then after getting that, it would construct a path that leads down to the area where the spans are. Okay, and then from there it would ask for the nth child, which that's whichever one you clicked on. So 1, 2, 3, 4, that'd be the fourth nth child. Normally it also collects the ID of what it's looking for and puts that in a locator strategy. And then during execution, what Context QA does is has a fallback to different strategies to see which ones actually fetches an item, and then it grabs the one that it prefers most, which also gave a successful fetch. But since we don't have ID, it couldn't use that. And this is, I'm mentioning Context QA because that's what I did the testing with. But even if you're writing the automation yourself, you have a similar problem. You have to decide what method you're going to use to find the item, and you're limited by what's on the page. Okay. So this worked when ran it initially, because even though getText wouldn't work, because the page generates random examples, that's its functionality. So getText would inevitably or high probability fail. It would fall down to this path-based thing to try to get, whatever item we'd selected from the list, and that was fine. But it was fragile because it's basing its locator scheme on layout of the page, the physical relationship of objects in the view of how the language describes the layout. Okay. This broke when I changed the inside of this into a table instead. So let's just, to illustrate that, let's clear that out, and instead reflect more what it looked like, as a table. Oops, wrong thing. Select none. Forgot to select a pen. Okay. As a column, where it'd say, value and then the number value and then the string value and the string. Like, so it was a little mini table inside of here. Okay, and as a table, the HTML looked like this. Of course, it had start of the table, then you'd have for each random string in there, you'd have the start of a row, the TD, the word, I think it was value is the word I had in there, and then close that. So that's the cell on the left, and then TD, the random string, and then close the TD, etc. Right, and then close the row, and then another one for the next one. And the problem with that is this pathing strategy was built for like a one level deep, and we're going into the spans that are underneath. But here, the pathing strategy has to deal with the fact that it gets into the table, and then it gets into with the right row, and then into the right column. So it's got like 3 levels that it would have needed to do before it can even talk about what's the nth child. And that, of course, did not work once we got to that point because the layout had changed and all of the mechanism for finding things was tied to the layout. So what we want to do is make a more robust way of getting those objects from the page so we can inspect them, manipulate them, do something with them. And to do that, we need to separate this notion of the visual expression, or more correctly, the code expression that creates the visual impression, and keep that distinct from the actual data that is underlying it, the data that are those strings, right? Because really we've got an underlying data that we're working with that has been represented as a view in another language, and that language doesn't work for us. And so let's talk about the data. Now we've got a relatively simple data problem in this one. It's not hard. We've got a set of things that we know are random examples. Okay, so that's conceptually that's what they are, and each one is some string, right? That's in that set, on down to however many of them there are. Okay, and so this notion of there being random examples is what we want to get that. We want to find it on the page somewhere to check it, look at it, do something with it, reason over it, right? And so what we'd like to do is have a way of identifying it that preserves that relationship. Now, when you're working with automation on web pages, one of the most robust structures, and I mentioned this before, is an ID. Because an ID is something that is findable no matter where it's at in the page. If you know the ID you're looking for, you say get element by ID and you can get it back. And that is nice because it detaches from visual relationships, right? It's still findable. You can also scope according to a visual relationship and say everything within here find the ID, but you could also do it from the top of the page if the ID is unique. And we have a chance here to make it unique. So we want to convey 2 pieces of information that tie it to our data set. First is that it belongs to the set of random examples. Okay. And that it has an ordinal value. which one is it in the set? This is, I mean, this is so simple it almost feels obvious to the audience. So we can create a rather simple string structure for the IDs. We can say for every single one, we just say random example. Let's just call it that. And I like to put separators and things like that between things just so I can tell when things are different from each other but go together. And then just take its ordinal value. So the first one in the list would be random example 1, random example 2, etc. And what this allows us to do is say, okay, it doesn't matter where it's at, if it's under, if it's inside a span, if it's inside of a table. Let's pretend that we had the random words in some like word cloud, making a cool looking little visual graphic there. Each one of those would have an ID that was associated with it that comes from the notion of where it is in our set of they are according to the data. And then we just get them by the ID. Right? And we've got it no matter where it is. And that makes a more robust mechanism for locating the item, no matter what we've done with the visuals, no matter what way we're expressing the visuals. And here I'm expressing it in spans and tables. And then maybe a word cloud would be expressed in some kind of graphic thing like SVG or something like that. So that is the strategy that we're going to use. Okay, let's take a look at this actually in action. So this is the data maker page, and we've got the dev bar up so we can see what the different parts are. And now if I go inside this list of random examples, which this particular object, it either says choice 1 or it says val 1, so it's not as much randomization. But if I click on any given one and say inspect, we'll see it over here under this div that says ID is random examples. We've got span ID equals random example underscore 5. So and likewise for any one of them we could select that one and it would be the same order in the page, even though the actual value in the text would change. So I'm going to just quickly click away from that and click in again so we get that same thing again. And you notice how the values are completely different. But if we 1, 2, 3, 4, 5, we say inspect, and it still takes us to random example 4. Well, 4 in that case, 5. It starts at 0, so that's why. And so the locator is robust, even though the contents inside the item are randomized. And that's what we did with this particular item. Let's take a look at what that looks like inside of Context QA, because I did some runs prior to making this change and then some runs after making the change. So this, let's look at this, the post new markup manipulate UI, right? And let's wait for it to pull up the steps, and let's pull up the run history. Okay, and these are 2 runs where I had changed the markup, and I had it on this first run looking like a table, and on the second run looking like a span. And we can look at either one of them, and we can see what it did when it was trying to find the items. Okay, there it is. Go through, find the schema list, random example. Okay, so you see here it is. It's got different fallbacks. It's like get by role, get here. It's got the possibility of looking for it by the ID. Okay, it's got trying to look for it by text, and it's just checking to see which ones are visible, right? Well, the one that was visible is the ID-based locator that we had designed in there, and that works. It's actually able to find it and didn't have a problem. We can contrast that with a prior test case before the new markup existed, where I recorded it against not having the IDs there, right? And let's look at what I'd done is I had made the page initially with just spans describing, and then I changed it to use a table to describe the random examples, and that's the one that failed. And we can see what it did in the failed case, right? And again, this is before my markup using IDs. It doesn't have the IDs to look for things. So now it's got to start trying to find them by other strategies, right? Here it is. It says, what's the schema name we're looking for. I'm not sure if I'm getting the right one here. Might have been something else. Yeah, here's the failure, right? It says, okay, I'm going to look for you by text. I'm going to look for you by something in the body, a body path. And in this case, it's looking for the 11th child of random examples. Okay, so it says, are you visible by text? Are you visible by this? Are you visible by that? And in fact, it's trying to see if it's visible by text using a locator. And this overwhelmed context QA. It didn't like that. But the issue is that it didn't have the ID to fall back on, right? It didn't have that to use, and that caused it to fail. So this particular failure is really a product of the page that we're testing having the lower quality markup inside. With our new design, it's got the ID to fall on, and it can find it much better, which would be the case for a self-healing technology like this, or the case for writing your own automation, where you've got much better things to use than locators that are more fragile.